in this video, I will be going through the YTSS Prelim 2022 Q07. So for Q7, I'm trying to check whether you have studied your DC circuit. The first and the last question are pretty straightforward. It is a recall kind of question. I'm trying to see whether you have memorized your circuit symbol and whether you can construct a short circuit. Sorry for this jumping of the screen. So now we are back. In the first question, I'm trying to see whether you have memorized the symbol for thermistor. So when you draw the symbol for thermistor, it is very important that you draw this line properly. It should cut through the entire box. Now then, there are some of you who mistaken this particular symbol as thermistor. This is wrong. This is actually your variable resistor. Then there are others who have actually drawn a diode, or you have drawn a light dependent resistor. So if you are still not sure what are the electrical symbol, I suggest you go back to your textbook and look at all the symbol that is found in the table. Now some of you are relying on Google to find electrical symbols. Some of them are not in your syllabus, and some of them are using different symbols. So you need to follow the one used by Cambridge. So the best way to do it is to just take out your textbook since you bought it, and then flip to the chapter on DC circuit, and you will find all the electrical symbol there. The second thing that you need to take note of is that I'm quite surprised there are some of you who still do not know how the resistance of a thermostat change with temperature. So for this particular one, the relationship is actually inverse. So there are three non-ohmic conductor that you need to know is behavior. Number one is tungsten, or what is his name? I think it's some light bulb thingy, tungsten. Tungsten is where the resistance will increase with temperature. Then there is thermistor, which is shown here. And then there is light dependent resistor, which also has an inverse relationship with light intensity. So please go and read up on that. Now, most of you got this question wrong. Many got it wrong due to part C. So for part C, I purposely give you this weird circuit presented to you in this way. So in your C part 1, you're actually supposed to find the current flowing through point R. So point R, you will notice that you are actually looking for the main current. So in calculation of DC circuit, right, if they ask you to find the main current, basically you can quickly simplify your question to finding the effective resistance, because most of the time the EMF of the battery is given. So if you go and apply V equals to IR to the entire circuit, then your entire circuit, then what happens is that you can substitute your EMF into the voltage, and the main current over here will be what you want to find, and this R will be the total effective resistance of the entire circuit. So if you have this in mind, then to solve this question basically is to find the total effective resistance. And to find the total effective resistance, right, basically you are I'm trying to check whether you can identify series connection, parallel connection properly or not. So I do not know why some of you like to skip things, even knowing that you yourself are weaker in this part of the topic. So what I suggest you to do is really to sketch it out. So here I have a sketch of the circuit in the question, and I place R1, R2, R3, R4 so that when I explain, you can see it clearly. So the first question you need to ask yourself is, can you find the first or the most obvious connection that is either series or parallel? So some of you may think that your your R3 and R2 are in series, but it is not true, because there's a junction over here, and for something to be in series connection, there shouldn't be any junction in between. So if you look at if you revisit the definition of series and parallel connection, the most obvious and straightforward connection that you see is actually between R2 and R1, and they are in parallel, right? So do that first. Don't go and do everything in one step unless you are like super confident about this topic. So R1 and R2, if you combine them, what happened is that the question actually tells you that R1, R2 each has 6 ohm over here, right? So if you combine them, 6 ohm, 6 ohm in parallel, you will end up with a 3 ohm resistor over here. Now if you do not know why, you can work out on your own. Okay, so now what is the next most obvious connection that you see? Well, again, like I say, if you are wicked in the topic, just spend some time to sketch it out. It is very quick, right? And you can see that actually now R3 and this newly combined resistance, which is 3 ohm, is in series. So R3 and 3 ohm now can be combined, right? And we know that R3 actually has a resistance of 6 ohm and they are in series. So in series, you can combine them, right? So after that, I combine these two and I end up with this guy. So series, if you combine them, you just add it up. So 6 plus 3, that will give you 9 ohm, right? And from the question, I also know that this guy over here is also 9 ohm. And you can now see it very clearly that they are in parallel, right? So if you apply the parallel resistor formula, you will end up with a combined resistance of 4.5 ohm, right? And you want to find the current that is flowing through R. You want to find this current, which is the main current. So if you look at it from the overall perspective, if you look at it here at the top, you want to find I main, and basically by combining your resistors, you can simplify the entire circuit into this, and you can still find the effective resistance. So with this, now you can apply your Ohm's law, V equals to IR. You apply it to the entire circuit, right? So when you apply it to the entire circuit, the V that we are looking for would be the EMF over here. So the EMF of this circuit is 9 volt, and then you want to find I of R, which is this guy over here, and then you have already found the combined resistance. So basically you have found the answer, just like that. Okay, so this is one way of approaching it. Another way of approaching it is slightly more difficult, but it is good as a practice. So what I do is that whenever I receive a question that shows such a complicated circuit, right, I will redraw it to something that will make me less confused. And the way to draw it is always identify all the branches that you see. So here you can see that when the main current goes to this junction, it will branch out like that. And then with this red color smaller branch, when it goes to this dot over here, it will then further branch into 2. So meaning that this current splits 2 times. And when the circuit is presented to you this way, sometimes you may forget. So what I do is that I will always redraw it like that to help myself visualize. So I will first start with the battery, right? So I follow this part. So the battery goes here, right? I will tell myself, oh, okay, now it meets the first junction, the first red dot. So then it will goes down. I will draw it vertically. I will I will redraw this circuit in a vertical way, right? Then I reach the first red dot, and in this first red dot, my current will first split like that, right? So one of the current over here, I will use black, will go to PQ, right? So I know that this guy go to my P and my Q, and then I will have my thermistor over here, right? Then after that, the other current, which is over here, will hit my first resistor, which I have named it over here R3, right? So I name it here R3. Then it will go to my R3. After going R3, I will hit another junction, which is here. So then I will go here, hit another junction. Then after that, it's going to split into 2, right? This one and this one over here. So then I will draw it as splitting into 2. Both of them are the same resistance, and I have called R2 and R1 here. So this is R2, this is R1 as I have labeled them. So then I will write here, so this one goes to R2, and then this one goes to R1, right? Then after that, these two branches of current will then merge over here, right, at this black color dot. So then I will draw it as it will merge back to this, right? Then after that, the merged current over here will then join this current, right, at this point. So then I know that now this guy will then join over here at this dot. So this dot is this dot. Then after that, the current will combine into the main current and go back to the battery. So I know that this guy goes back to the battery. So when I draw it this way, I can see very clearly how the current split is like drawing some how the water get funneled down a building like that, right? So for those of you who have trouble answering calculation question regarding DC circuit, you always make mistake. My suggestion to you is you redraw the circuit in this vertical way so that you don't get the wrong visualization, because sometimes you may feel that, oh okay, I have a 9 volt here, so therefore this guy is 9 volt, this guy is 9 volt, this guy is 9 volt. So this kind of layout will give you that illusion that it seems that the battery PQ, R2 and R1 are in parallel, but in fact they are not, and they are not because of this guy over here, right? So by redrawing this circuit this way, you can see that this battery over here cannot be parallel to, even if I shift this battery, right? If let's say I shift the battery to here, right? Let's say I draw the battery over here, right? You can see now very clearly that okay, the battery is parallel to this guy, but definitely not parallel to R3 or R2 or R1, right? So by redrawing your circuit in this vertical manner, it helps in your visualization. Yeah. So let's move on to the next part, which is to find the current in point S. So to find the current in point S, right, you are actually finding the current flowing through R2. So if I were to use this, you can see that, oh okay, now I need to know the current flowing through R2. This is my target, the blinky one, right? So to find this, there are many ways. You have to apply the right, you have to apply V equals to IR to the right position of the circuit. So what I'm going to suggest you to do is, again, let's do it the slow way, and the slow way basically is to again you know, you can redraw the circuit to help you better visualize the thing rather than you do it mentally. And when you do it mentally, sometimes you are not that familiar with circuit, and you yourself also insecure, so you may make mistakes. So let's say for this point S, right, I want to find this current, right? This is the current that I want. So I need to know, I know this R2, I know this R2 is 6 ohm. But do I know is PD? I do not know, because even though I know this is 9 volt, this guy over here is not parallel to this, and I have shown you why, right? So for example, this is the battery, definitely not parallel to R2. Now for those of you at this point you still don't see why R2 is not parallel to the battery, please come and see me, right? Because it is a major misconception. So now I have this problem of finding the V over there. I can't apply my V equals to IR directly to this to find my current flowing through R2. So what I do is that, okay, never mind. What I'm going to do is, I know R1 and R2 both are 6 ohm. Meaning to say that I know this red color current, after it passes through R3, is going to split equally into these two branches. So in another word, if I want to find the I going through R2, I first need to find the I flowing through R3. And I can do that quite easily by simplifying the circuit. So what I do is, I do the same thing. I combine R1 and R2. And once I combine R1 and R2, I would know that my new resistance over here, the combined one, is 3 ohm, right? My R3 here is 6 ohm. And I can further, and my target is to find this current over here, right? So to find this current over here, I'm going to further combine the R3 with my new 3 ohm resistor, right? And because they are in series, this guy over here and this guy over here in series, right? I can work out that this is 9 ohm, right? And like I said, I want to find this current, right? Why do I want to find this current? Some of you may have forgotten is that once I find this current, I can find this current going through R3. Once I know the current flowing through R3, because these two resistors are the same, I can just split up this R3 current into this one, and I can find my answer, right? I want to find the current going through R2, right? That's my original target. So now that I'm at this step, it becomes very easy for me to find this, because I can see now that my battery, my thermistor, and this guy are in parallel, right? So what I'm going to do is that, let's say I call this the R6. I don't know why I call it 6 lah. Okay, so what I'm going to do is that I'm going to apply V equals to IR to R6. So I have V6 equals to I6 R6. So V6 will now take on the voltage of my EMF, which is 9 volt. I6 is the thing that I want to find. This is my I6, right? And my R6, I have worked it out, is 9. So with this, I know that my I6 is now 1 ampere. So now I know that this guy is 1 ampere. So once I know that this guy over here is 1 ampere. And now I know that this guy over here is 1 ampere. And it is going to split into this and this equally. So I know that now this guy over here is going to have a current flowing through it, 0.5 ampere. Can? So that's how you do the calculation over here. Okay, in part D, some of you, whenever you see this kind of question, whether it is talking about brightness of a light bulb or whatsoever, please remember brightness or whatsoever depends really on the power. So even if I'm asking you whether the light bulb is brighter or dimmer, we are not asking you to check whether the V has dropped or the I has dropped. Okay, for something to be brighter or working harder, we are actually looking at the power of the thing. And for electricity, there are 3 formulas to describe power, and students always have the difficulty in picking, which formula should I use? Why is it that sometimes my teacher use I square R, sometimes I use V square over R, and sometimes I use VI? So it is very contextual, and you need to be smart about it. Now let's use this example to share with you how I go through my thought process and pick the equation that will work best for a particular situation. And in this video, I will also share with you that actually whether you use equation 1, 2, or 3, if you do it correctly, eventually you will reach the same conclusion, right? So let's try. Okay, so now I am given a situation whereby I know that the resistance of my thermistor has dropped. Now the first thing that comes to my mind is that, okay, if I know that resistance is going to change, I want to see resistance in my formula. So out of the 3 power formula, 2 of them has R. So I know that, okay, I'm going to use either one of them because it has R in it, right? I know that my resistance is going to drop, right? So this means that if I want to establish a relationship between R and P, the best case scenario is that I want the third parameter in my formula to be constant, right? Because once that thing is constant, I can quickly establish how the drop in R will affect my P, right? The worst case scenario is that the third parameter, the one in blue, actually rises, right? And it gives like a sense of neutralizing effect, then I would have problems. So I want to use a formula whereby R has dropped, the third parameter in my equation should be a constant, and that will give me a clear indication on how P changes. So I don't know which one to use, right? I need to decide which one will give me a easier way of explaining myself. So I return to my circuit and I look at it. Okay, the thermistor is over here, and I can already quickly see that from our previous discussion, my battery is parallel. And once I know that things are in parallel, I know that this guy is going to be 9 volt and this guy is also going to be 9 volt. No matter how R4 has changed its resistance, the PD doesn't change because the PD comes from the EMF, right? And because as long as this R4 and this thermistor and my battery are in parallel, no matter how the resistance of my R4 changes, I'm going to get back the same V. So now I have found a parameter that is going to stay constant no matter how its resistance is going to change. So very quickly I know that I'm going to use this formula. This formula will give me the easiest way out because I know that now my V over here is going to be staying constant, right? I should use a smaller font. I know that this guy is now going to be constant, right? So now this means that it's pretty straightforward, right? My denominator in this fraction R is going to drop, right? And when my denominator drops, I know that my P is going to rise, right? So I can explain this very easily, right? When the resistance of my thermistor drop, the PD across my thermistor is not going to change because it's connected in parallel with my EMF. So by P equals to V squared over R, V is constant, R drop, I will know that my power of my thermistor is going to rise. Full stop, 2 marks, right? So that's how I solve my question. Now what if I see it wrong? I didn't notice that they are in parallel, right? I didn't notice that the V is going to be constant. And I decided, okay, let's go ahead with I squared R because somehow I can only remember I squared R. I have forgotten the formula V squared over R. Am I going to get wrong in this? So you need to go back to here and you ask yourself, okay, now I need to go and find out how my I changed, right? Because you want to use this formula, right? So you are going to apply P equals to I squared R to R4, right? So you want to find power of R4, you will definitely need current of R4, right? So how do I find current of R4? I know that R4 is going to be 9 ohm. I know the V, I know the R, I want to find the I. What formula should I use? Well, I hope you can recall that. The formula to use would be V equals to IR, right? But in this case, you want to apply it to R4, right? So V of R4 is going to be the same as the EMF. So in another word, constant. You have I4 and R4, right? So now you know that this guy, you know that this EMF is going to stay constant. You know that your R4, according to the question, is going to drop, right? How would your I4 change? It's going to rise, right? Because you need to keep the V constant. So now you know one more piece of information. Your I is going to drop, right? Down here, your I is going to drop, right? As your R4 here is, your I4 here is going to rise, right? As your R4 resistance is going to drop according to this formula. So now you go back to this. It is a bit tricky now because your I is going to rise, right? Remember I told you this is like the neutralizing effect thing. But don't forget, your I is not just IR, but it is I square R. So because of the power of 2, the rising effect is going to get square. So because of that, it will take a dominant role. So even though R drop, but your I is going to rise to the power of 2, your power is going to rise as well. So you see, you can reach the same conclusion over here, that I rises. Okay, but if you are using this formula, then your explanation will be longer because you need to justify how do you deduce that the current is going to rise, right? So how do I do that? Well, I would say that first, I need to apply Ohm's law, V equals to IR to my R4. The V across R4 is going to be constant. Then, as my resistance of R4 drop, I would now know that my I4 would rise, right? And when my I4 rises, according to P equals to I squared R, is going to rise with a power of 2, and hence my power is going to rise as well. Right? Can you see that it is a much longer explanation than this because you need to include this chunk of stuff? But you will get back the same conclusion that power rises. How about the last one? The last one is going to be a nightmare. because you need to talk about both V, and you need to talk about both I. So essentially you need to combine the explanation of both of this. First, you need to tell me that the V over here is going to be constant because they are connected in parallel. R4 and the EMF is in parallel. So first you need to tell me that this V over here is going to be constant because your EMF and your R4 are in parallel. Then you have to justify and tell me that this guy is going to rise, and that is because your V square V equals to IR. If you apply it to R4, the thermistor, you are going to get here constant. This guy drops, and then hence this guy will rise. So essentially you need to tell me that this guy rises and this guy become constant, and hence this guy will rise. And you will notice that in all three approach, your power is going to rise, right? But like I said, that this one will give you the easiest way to explain. This one slightly harder. This one you are just asking for it. Yeah. So I cannot tell you which formula to use, but my rule of thumb is that if that component is in parallel, I will always use this because I will know that V is going to be constant and it give me an easier life. If I know that the thing is in series where current is constant, I'm going to use this because I know I don't need to take care of I, right? And if really got no choice, I will then use this. And P equals to VI most likely is going to be used in power rating, is going to be in power generation. That's all. Yeah. So I hope by watching this video, you have learned a bit. In this video, I have covered how to change the layout of the circuit so that you can see how the current actually cascade down like some fountain or waterfall. I have also shared with you one tip. If you were to find the main current, basically you just need to find the total resistance, total effective resistance, right? And I suggest to you that if you are not very good, you know that you are not very confident in your DC circuit calculation, just sketch the circuit in pencil or whatever. You can always erase. You don't need to draw it like in sequence like me because I'm going through the paper with you. You can just draw it in pencil, and then as you combine the resistor, you can always erase the branch, and it will help you in your visualization. A lot of you are doing it in mental. As I mark your paper, I can see that you're working, shows that you did a lot of the calculation and deduction in your brain. And sometimes due to stress or whatsoever, you will not be able to, you are going to make mistakes and you are going to arrive at the wrong thing. Yeah. And lastly, don't be afraid when the question asks you about power, about brightness, always go back to the power, right? And then from the power, write down the three equations in pencil, and then ask yourself, okay, if R is going to change and I want to deduce power, let's keep the third one constant, and then you look for opportunity in the circuit to see which parameter will go constant. Is it the V or the I? Okay. So always remember when people ask you about brightness and whatnot, always go back to the power. Okay, I hope this video will help you.